Yes, students, now we are going to see another one example, the longest chain of carbon compound. So here in this CH3, CH2, CH, there is a substituent CH2, CH3, another CH, CH2, CH2, CH3 is another substituent, CH also CH, CH2, CH substituent, CH2, CH2, CH3. So these examples are in your higher standards, higher classes for our practice I am giving. So here see, we have to number the carbon atom. We take the linear pattern. It is number the carbon atom 1, 2, 3, 4, 5, 6, 7, 8 carbon. 8 carbons are there in the longest chain of this carbon compound. So 8 carbon means what is the parent hydrocarbon? Octane. Octane. It is actually see oct. Octa. Octa means 8. Octa means 8 plus A and E, because all are single covalent bond. There is no double bond here. So octane. Oct plus A and E. Octane. This is the root word and the parent hydrocarbon of this compound. And see, actually there are three substituents are given here. See, this is one substituent and another substituent and another substituent. Three substituents are attached with this longest chain of carbon compound. CH2, CH3. What is the name of this substituent? This is going to be a ethyl. Ethyl. Actually, this is obtained from ethane. This is obtained from ethane. That is a CH3, 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 CH3. In this replacing one hydrogen, in this removing one hydrogen, this alkyl group is obtained. So this is going to be ethyl. Similarly, this is going to be propyl. This is going to be propyl. And also see, this is also going to be propyl. Propyl. So two propyl groups are there. So one ethyl group, two propyl groups are attached with the longest chain of carbon compound. And we have to give suffix based on this substituent. So, the prefix. The prefix are based on the presence of substituent. So, here with the third carbon, ethyl is attached. With the fourth carbon and fifth carbon. With the fourth carbon and fifth carbon, propyl is attached. Two propyl is attached. Two propyl. So which is why we are going to try dipropyl. Dipropyl. And what is the root word? Octane. Octane. So the name of the compound is 3 ethyl. As a third carbon, ethyl is attached. 3 ethyl, 4 5 dipropyl. Dipropyl, because two propyls are attached with the 4 and 5 carbon. Octane. Dipropyl octane. This is the name of the compound. So it is very simple, but only regular practice will help you to understand and write the name of the IUPAC, the compound easily. Then see the next one example. See CH3, CH2, C, CH2, CH3. And see you go through the longest chain of carbon. See 1, 2, 3, 4, 5. So pent plus A and E, single covalent, pentane. So the name of the hydrocarbon is pentane. Pentane. And see with the third carbon, two methyl group is attached. Two methyl group, the third carbon. Third carbon contain two. So 3 dimethyl. Dimethyl pentane. Dimethyl pentane. Then so see sometime also we can write 3 3 dimethyl pentane, because third carbon 2 methyl group is attached, 3 dimethyl pentane. Then move to the next example. See, there is CH3, CH3, CH2, CH3, CH2. So here also see only single bond is given. So the parent hydrocarbon is alkane. So you have to number the carbon 1, 2, 3, 4, 5. 5. Pentane. Pent plus ANE, pentane. And so we have to check the substituent. Here one methyl group, here one ethyl group is there. So with the second carbon methyl is attached, and third carbon ethyl is attached. Second carbon methyl, third carbon ethyl, and pentane. Usually we write like this, but according to the IUPAC pattern, that ethyl will come first. According to the alphabetic order, E will come first, then the M. So 3 you have tried 3 ethyl and 2 methyl pentane. 3 ethyl, this is a third carbon, ethyl is there, second carbon methyl is there. So 3 ethyl, 2 methyl pentane. 3 ethyl, 2 methyl pentane. This is the name of the compound. So my dear students, we can write the IUPAC name of any compound based on the root word. First we have to check what is the root word by numbering the carbon atom, and check the presence of substituent or functional group, and we have to locate the double bond and triple bond, get the lowest possible local number. So based on this replacing E, addition of OL or AL or ONE, we can give the name of the compound based on the IUPAC pattern. So you practice, you try to practice all this compound, and it will be easy for you. Only by regular practice we can obtain to write the IUPAC name of the compound. Thank you. Yes, my dear students, now we are going to study about some other examples for naming the organic compounds using the IUPAC pattern. See here, actually in the linear pattern there are 4 carbon, 1, 2, 3, 4 carbon. 4 carbon, but actually according to the IUPAC pattern we have to check the longest chain of carbon atom. Is there any other possibility to get more number of carbon atom in the chain? See, in the linear pattern 1, 2, 3, 4 is possible. Also we can move from this onwards, from here to here, then to here. So 1, 2, 3, 4, 5. 5 carbon is possible in this way. So we can give number to the carbon atom. We can give number to the carbon atom. That is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the longest chain of carbon in this organic compound. So 5 carbon means what is the root word? Pent. Single bond. So A and E. Actually this is going to be a pentane. This is going to be a pentane. And also see, there are 2 substituents are there. Here one substituent, here one more substituent. So CH3 is nothing but CH3 is methyl. CH3 is methyl. So this is obtained from the methane. This is obtained from methane by replacing one hydrogen. By replacing one hydrogen, methyl group is obtained. Methyl. So there are 2 methyl groups are in this organic compound. One methyl group with third carbon, one methyl, fourth carbon one more methyl. So 2 methyl, actually 2 methyl, same substituent. So we can write dimethyl 3,4 dimethyl. So 3, 4 dimethyl 3 and 4 2 methyl dimethyl pentane. Dimethyl pentane. This is the name of the compound. Then we can go to the next one example. See, CH3, CH, CH2, CH2, CH3. Here see, we have to number the carbon atom to check the root word. So 1, 2, 3, 4, 5 carbon. So pent, single covalent. So pentane. Pentane is the usually the name of this parent hydrocarbon. And here see two substituents are there. Two substituents. Here see one methyl with the second carbon, another methyl with the fourth carbon. So 2, 4, 2 second carbon, 2, then fourth carbon, 2, 4. What is the name of the substituent? Methyl, 2 methyl. So 2, 4 dimethyl, 2, 4 dimethyl pentane, 2, 4 dimethyl pentane. Yes, my dear students, now we are going to study about the IUPAC nomenclature of other classes. For example, compound CH3, CH2, CH2OH. Let's see, functional group is given. Functional group is given. This is OH. This is going to be alcohol. And see, we have to check number the carbon atom to find out the root word. So there are 3 carbon, 1, 2, 3, 1, 2, 3. So 3 carbon means the root word is propane. Actually, the root word is going to be propane. Propane. And see, in the propane, what is given here? Functional group OH is given. OH is given. So we have to replace C. Addition of OL. So what will we get? Propanol. So replace E and addition of OL, propanol. And also we have to locate the position of functional group OH. So the OH is attached with with the carbon, first carbon. So how to number the carbon? That carbon contained functional group should get the lowest possible number. So we have to number the carbon starting from here. 1, 2, 3. So with the first carbon, OH is attached. With the first carbon, OH is attached. So we can write, that is the name of the compound is propanol. Propanol or propanol. Or also we can write 1 propanol. That 1 refers the location of functional group. The location of functional group. Propanol is the basic name. By numbering the carbon atom based on the presence of hydroxyl group, we are going to give propanol or 1 propanol. Then one more compound is given, say CH3COOH. So how many carbon here? Only 2 carbon. So what is the root word? That is going to be a ethane. Root word eth. Actually, root word is eth plus ane. And you have to see there is a functional group. This is going to be a functional group for carboxylic acid. Functional group of carboxylic acid. So when we are going to write, what we have to do? We have to replace E and addition of OIC. acid when carboxylic group is given. So it will come, it's going to be ethanoic acid, ANE, and replace E, addition of OIC acid, ethanoic acid, ethanoic acid. Then also there are some samples are given, that is first one, see CH3CHO, CH3CHO. Here see how many carbon, you have to check how many carbon, 2 carbon. So what is the root word? Eth. And here see, actually this is 2 carbon means going to be ethane is there, and CHO, this is the functional group of aldehyde. This is the functional group of aldehyde. So aldehydes are end with the suffix of aldehydes are going to be Al. Suffix of aldehydes are Al. So replace E, remove E in the name of the parent hydrocarbon, remove E and addition of Al, that is going to be a ethanol, end with Al. It's very important. For alcohol, the suffix is going to be OL, but for aldehyde, suffix is going to be Al, ethanol. Then also you can move to the next one example. See 1, 2, 3, 4 carbon. 1, 2, 3, 4 carbons are here. 4 carbons are here. So we can give the name. This is going to be butane. The name of the parent hydrocarbon is butane, because from the butane only the compound is derived. So here, what is the functional group here? CO is the functional group. CO is the functional group. CO is the functional group. So when CO is present, what we have to do in the parent hydrocarbon? Replace E, addition of ONE. Addition of ONE. So ONE is the suffix added to the hydrocarbon having the functional group of CO. Having the functional group of CO. So what will be the name? BUTAN, butanone. Butanone is the name of the compound. Also we can write based on the presence or location of CO, we can number like this 1, 2, 3, 4 and see 1 butanone. We can give number and write 1 butanone or but 1 one also we can write. Then see the next compound. This is Cl, and is a substituent. Cl is a substituent. Then CH2, CH3. So there are how many carbon? You can check it. See 1, 2, 3, 4 carbon. 4 carbon. So parent hydrocarbon is the root word is but. Parent hydrocarbon is butane. And see, there is a substituent here. There is a substituent. So what is the substituent here? See, chloro. So that substituent, name of the substituent going to be a prefix. So what is the position of substituent in the first carbon? So 1 chloro. So here this is going to be a butane with a single covalent bond. And one substituent is there. So 1 chlorobutane. 1 chlorobutane. And also students, there are so many examples are there. We can write so many examples based on the IUPAC rule. We will see the example in the next session. Yes, my dear students of 10th standard, we are going to learn about the IUPAC rules for naming organic compounds. So according to the IUPAC pattern, there are 6 rules are given. First we have to find out the root word by checking the number of carbon atom. Then we have to give number to the carbon atom based on the presence of substituent or functional group. And third rule says locate the presence of double bond or triple bond. Fourth rule says use local number for the functional group substituent. Then in the alkene, the terminal E is removed. Then identify the substituent for the prefix. So these are the 6 rules. Now we are going to see the example. Example 1 take. See CH3, CH2, 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 CH3. See there are 5 carbons. So there are 5 carbons. That is it is a linear pattern. There is no branch and there is no substituent and there is no functional group, and 5 carbon. We can give number to the carbon 1, 2, 3, 4, 5. If 5 carbons are there, it is a linear pattern. There is no substituent, so there is no functional group. So only 5 carbon. So 5 carbon in the longest chain of hydrocarbon means the root word is pent. Root word pent. And also we can see what is the hydrocarbon pentane. Pent plus A and E, because all are single bond. If it is a double bond, we are going to write E and E. Triple bond means Y and E. It is a single covalent bond. The bonding between the carbon atom is single covalent bond. So 5 carbon, root word pent, and the suffix is going to be A and E. So the name of the compound is pentane. The name of the compound is pentane. Sometimes we can also write N-pentane. N-pentane. It is called N means a normal pentane. Normal pentane because there is no branch, there is no substituent, there is no functional group. So we can call it as a normal pentane. Then you can take the next example. See here CH3, CH, CH2, CH2, CH3, and in the second carbon from the left hand side, one substituent is given, that is methyl group. CH3 is methyl group. So we have to number the carbon atom and we have to check the root word. What is the root word here? See, we have to find out the longest chain of carbon atom. Here see 1, 2, 3, 4, 5 carbon. So root word is pent. Root word is pent. And here see all are single covalent bonds. So A and E, A and E, and there is a substituent with the second carbon. There is a substituent with second carbon, that the CH3 is called methyl. The group of CH3, that is methyl. So to the second carbon, methyl is attached. Methyl is attached. So we can write, that is 2 methyl pentane. 2 methyl pentane. So this is the name of the compound. We can attach here. So 2 methyl will be a prefix. That is the phrase before the root word. Phrase before the root word. So already you know what is the formula to write this IUPAC name. First we have to write prefix, then root word, then suffix, then IUPAC name will be obtained. So this is a simple formula prefix, root word, suffix, and the IUPAC name. Then one more example is given here. See, you can go through this example by numbering the carbon atom. So there are carbon atoms 1, 2, 3, 4, 5, 6 carbon in the linear pattern. The linear pattern. So according to the IUPAC rule, we have to find out the longest chain of carbon atom. Longest chain. And if we go from here, from this way, we can get the longest chain with a more number of carbon atoms. That is 1, 2, 3, 4, 5, 6, 7 carbon is possible. So we can give number 1, 2, 3, 4, 5, 6, 7. 7 carbon, the longest chain of carbon atom of this hydrocarbon. So 7 carbon means that is going to be, what is the basic hydrocarbon or root word, that is it is heptane. The name will be heptane. And we have to see here only a single colon bond. So ANE, the suffix is going to be ANE. There is no double bond or triple bond. And here one more substituent is attached with the third carbon. What is the name of this substituent? Methyl with the third carbon. So we can write 3 methyl heptane. And next we can move to the one more example. There is you take this one says CH3, CH2, CH, double bond CH2. So first we have to go through what is the root word. What is the root word? The rule one, according to rule 1, 2, 3, 4, 5 carbon. So the root word is pent. And usually if it is a single bond, we have tried ANE. But here double bond is given. So instead of ANE, we have tried ENE. Double bond means that is alkene. Alkenes are end with ENE. So the suffix will be ENE. And we have to number the carbon atom. How to number carbon atom from this way or that way? See, according to the rule, we have to check the position of the double bond. The double bond carrying carbon should get the lowest possible local number. Double bond carrying carbon atom. So this is the double bond carrying carbon atom. This double bond carrying carbon atom should get the lowest possible local number. So we have to start from right hand side. So number the carbon atom 1, 2, 3, 4, 5. Not from left hand side. If we start to do like this 1, 2, 3, 4, 5 means what? This double bond carrying carbon going to get lowest possible number. That is not the rule. So the double bond carrying carbon should get the lowest possible number. So we have to start from right hand side. Then so pentene, actually the name of the compound is pentene. This is the name, no actual name, but we are going to mention the presence of double bond also. We are going to mention the position of double bond also. So with the first carbon, double bond is there. So we can write pent plus 1 plus Ne. Pent plus 1 plus Ne. So pent dash 1 in. Or also we can write sometime 1 pentene. So this is the way of writing IUPAC name. So pentene. The place of double bond carrying carbon is 1. So pent 1 in or 1 pentene.